I don't know if I could go 45 minutes. Oh, it's so great to be here today. India, okay. What are we doing here? Let's take a quick survey, see where we're at. How many people here have heard about Node.js? Hands. Woo! Yes! Yes! How many people have actually used Node.js? Woo! Okay, one last question. Has anyone heard of the frameworks Hook.io or Flatiron? Yeah? Okay, got a couple. So what are we doing here? So, where to start? So in 2006, I saw a movie, Iron Man. Maybe some of you have seen it, maybe not. In Iron Man, the protagonist is a character named Tony Stark, and he does a bunch of cool stuff. He has a metal suit. I won't get into that part. He had a computer program called Jarvis. This was his digital assistant. And in the movie, he's constantly just saying things at the computer, and the computer just magically executes it. And I thought to myself, I want that. So I've been building that pretty much ever since. The software that I've attempted to write to solve this problem has existed in about 9 different versions. The first 4 versions were written in various languages, C, C++, Python, Java, I tried Cold Fusion. Finally came back around to using Node.js and JavaScript, starting with the 6th version in about 2009, when Node was first coming out. 7th and the 8th version of the software are now powering my previous company, Node.js, which is a hosting platform for Node.js applications. And now, the 9th, the 10th version, I've lost count at this point, we're releasing today. So essentially, this software is the epitome of the past 6 or 7 years of development for me, attempting to build Jarvis, the ultimate computer program. You can kind of just tell it to do something and it'll do it. So we'll see how far we've come along. So all this stuff has been private for the past 5 or 6 months. I've been working out with a few people. So the first thing that we're going to do to get started is we're going to start releasing this stuff on GitHub. So this is the resource engine. And we're going to make this one public. So there's going to be 3 libraries we're going to be covering today, all part of the same suite of tools. Please the name. So this is the resource project. And I don't have any slides. What we're going to do is we're just going to go through each one, go through the documentation a bit, and then maybe do a few code examples if we have time. So this is the resource engine. If anyone's online, it's GitHub/big company. Oh, and if you saw the announcement, this is a big announcement. It's actually the big announcement. The name of the software framework is actually called Big. So it's a big announcement for Big. So now this is public. So what is a resource? So resource is a resource as in RVP pattern, resource view presenter. If you're familiar with MVC, you can kind of think of a resource as your model and your controller merged together with some really good validation logic and nice features. So we're just going to go through the documentation. The package name is called resource. If you've used npm before, so the Node package manager, you can just install it. And we'll just go top to bottom real quick. So you can imagine you require the resource package, and we're going to build a creature resource. So we define it. We're going to add a property title. So this is saying we now have a resource called creature, and we're going to give it a property of title. So it's just imagine a model creature, and then a property of title. You can also add resource properties with JSON schema. So this is just a string property with no validation, no additional information. You can also use JSON schema to specify validators and specify schema. So in this case, we have a property called type. This is a type creature, which is it's a string, and it's restricted by an enum. So it can only be at least 3 values. And the default value is drag. We also have a property light, which is a type number, which has a default value of 10. This is a numeric 10, yeah. So now that we have this creature, we need to actually do something with it. So one of the most common use cases is persisting resources to a data source. Essentially, you're taking the creature and you're saying it needs to exist in a place where we can store it. A file system, a database, something along the lines of that. So here, we say persist creature to memory, yeah? We can also do file system, MongoDB, couch, etc., etc. The persistence engine is backed by a library called Juggling. It supports about 9 characters right now. It's well supported library. And now we have this new method called create, which allows us to create an instance of the creature with specified properties. Now, previously to call persist, this create method would not exist. Since we are telling the resource to persist somewhere, like the file system or memory in this case, additional methods are added, such as get, destroy, update, find. So this is your basic CRUD functionality, create, read, update, destroy. And it's all automatically built for you. You don't have to actually worry about implementing that. So that's cool. if you want to persist things. But if you have a controller, not everything is just going to be CRUD. You're also going to want custom methods on your controller. So resources support custom resource methods. So there's a method called method that allows you to declare a resource method. So in this case, we're saying create a new resource method called poke. And then this is the code to execute, just return poke. Additionally, you can add resource methods with JSON schema or arguments. So this is kind of like those who use dynamic languages or dynamic software are kind of forced to re-implement type checking and validation at runtime. If you're using a statically compiled language like C++ or C, you don't have to deal with any of this stuff because you have types and you have a type system. JavaScript doesn't really have a type system. So what we do here is that by specifying a schema for the method signature, all the validation is handled at runtime for us by the framework. So in this case, I'm saying create a new method talk, bind it to the talk function, which is up here, and then we have the argument, but then we're actually going to specify a JSON schema for the arguments required true. So if we try to invoke creature.talk and we didn't pass it the text argument, the framework is intelligent enough to either throw the error if it's a synchronous method or to continue forward with the error if it's an asynchronous method.
Well, a couple of questions.
Sure.
One is .persist is a synchronous function.
Yes. .persist is a synchronous function in that it enables persistence. So
it enables.
Yes. So prior to calling .persist, .creature doesn't exist on the resource. Yeah. So it injects the method on top. So yes, this is like persistence.enable is what this maps to internally, right? So this is just the sugar syntax for doing that. So yes, it's a synchronous.
That's cool. Then second question is adding resource methods. Are you actually pulling variable names out of the function definition and using those for
No.
checking that you have?
That is way too smart. I'm not that smart.
How do you say text?
So I'll show you. Talk, yeah. So talk is the name of the method, yeah. So that's a string. And then this is the function, which is defined here. And then the arguments. So I'm not pulling it out of the argument scope, I'm declaring it explicitly as the schema. So that's the whole point of doing the schema, yeah. Does that answer your question?
Yeah.
Okay. So this is a simple schema with one argument, no callback, no options hash. So you can also specify resource methods with complex JSON schema for arguments. So in this case, we're making a fire function for fire and laser. It has an options hash and a callback. This is a fairly common signature in Node.js or JavaScript in general. And then, as you can see, we have a schema for fire. So fire, and then binding to the method fire, description, and then properties. So this is JSON schema. So we have an options hash of type type object with properties power and direction. And then power is a number and direction is a number. And we also have a callback, which is required. So if we execute the fire method and we don't specify options.directions or options.power, which are expected, it's going to intelligently throw an error. So normally what you have to do in JavaScript, which is a huge pain in the butt, is that in every method you have to say if type of options.direction equals undefined, then set the default to do this. And it's just like, so you do it in every method. So that's go. It's all handled automatically. So what else can resources do? They've got basic hooks, so every method on a resource is hookable, whether it's custom or persistence method. This is extremely useful for things like logins, or if you want to do a permissions check before you execute a method on a resource. So it's very simple stuff for the name of the method, etc., etc. You get the scope, you get the continuation. Resources are common JS modules. You can export a resource in a common JS module. It just exports the name of the resource equals the resource. And then this is one of my favorite parts, is that resources support NPM dependencies. So NPM is the Node package manager. So who's the guy talking about the bundles? That was you, yeah? No, the bundle guy, yes. So you might have dependencies that are specific for a bundle or for a resource. And the thing is that you don't want to specify those as dependencies on the application. You want to specify those as dependencies on the resource level or the bundle level. So that's what this does. So in every resource, you can export a dependencies hash, which follows the same exact format as package.json for NPM. And this allows the resource engine to know that this specific dependency is needed for this specific resource. And this is useful because when you use your resource in an application, first off, it's a common JS module, so you could just require it. And it requires a synchronous operation, and you just pull the whole thing in. That's cool. But if you use resource.use, it's going to intelligently load the resource, lazily install the NPM deps, and defer any of the resource method executions until the dependencies are resolved. So For instance, if I call http.start, which is the HTTP resource, it's going to defer the http.start call until connect and express are fully installed from npm. Once the npm installation is completely successful, it's going to execute the deferred methods. So we'll get into that. Okay, so we have this concept of a resource. We can like build resources, and that's cool. We can specify methods and properties. That's great, but it's just an engine. It doesn't really do anything. So what we need is we need additional resources. So now we're going to open source another library. So resources library. Go to the danger zone. Make some resources. Open source. Yeah. Okay, so now resources, big company resources. So we have the concept of a resource. We can specify properties on it. We can specify custom methods. We can specify dependencies. So let's actually build something. Yeah. So I've gone ahead and built a bunch of resources that do a bunch of stuff. These are all open source. These are all on here. Feel free to go through them. I'll go through the list real quick, top to bottom. Sure, why not? So user accounts, web-based admin panel, which we'll go into. API for auto-generating REST and socket APIs, a CLI for automatically providing command line interface, Creature, which is one we did, cron for managing cron jobs, data sources for persisting resources, data source engine, documentation. So let's look at this real quick. So this one we can stop. So if I click on account, so account is a resource, and resources have properties and methods, and resource methods have a schema. So it's like, why don't we just introspect the whole thing and reflect the documentation? Oh, sick! So now this is all auto-generated, right? So we have fully functional documentation for every single resource, and I didn't type any of this. The documentation generator was able to introspect the resource and then reflect the definition of it across a RAID file in this case. So this is really neat. If you make any changes to the resource, and you'll see this as a theme throughout the entire framework, is reflection. We introspect the resource because it's so easy to enumerate and just reflect it across all these different interfaces. So documentation is a simple one. We'll get into more complex one. So docs, email for sending emails, there's a full functional form generator, there's a GitHub resource for interacting with GitHub API, there's a hook system, which we're going to get into. HTTP, IRC, there's a mesh for doing P2P mesh between machines. So you can have two machines, start up the resource on each one, and then kind of get a mesh customer in between. You get a node for managing node objects, permissions, REPL. Replication and replicator is pretty cool. I'm going to go to that in a second. So one of the resources enables git push and git pull, so that if you want to get a copy of an app, you can just pull from the master instance, and then it's just going to do it all locally. If you want to push a change, you can push. Using Git. We'll get into that. Resource, meta resource, sockets for socket.io, SSH interface. This one's really cool. So there's a virtualized SSH interface with resources. So if you use the SSH resource, you can SSH the IP address, and then it's going to use the CLI, and you get the full CLI experience in an SSH window. So if you need to do remote administration of a resource, you can just SSH into the box if you need to. And then that hooks into the account system. So if you want to create a new user for SSH, you just create an account. It's all put together. Standard in, standard out. System is pretty neat. That one, I guess. The tagging system, Twitter, video, view, virtual host. So it does a bunch of stuff.
Marak, just to clarify, the SSH is the SSH server.
Say again?
The SSH resource is the server, not the client.
No, it's a server, yeah.
Okay.
The way that it works is that it's not, it uses the built-in SSH server, and then we have this guy here, and it spawns a copy of Big as a CLI, and then it wraps the standard in and standard out in a script. So what happens is when you SSH in, you get a welcome script, which is essentially the CLI being served, and then you're in a little sandbox, and the only commands that you can run are resource commands and resource methods. Just a little bash script. This is really cool stuff. We'll get into this in a little bit. So we've got all of our resources now. So let's actually dive into some of these. So okay, so now we'll open source the last piece. So we have resource, which is the engine for creating resources. And then we have resources, which is a collection of useful resources. So now we kind of have to put them all together in the framework, which is called Big. So we'll make this public. And then I'm going to do something a bit unorthodox. I'm going to read through every single line of the Big framework right now. So big is a pretty big application. I think it's about 7 or 8 lines right now. So like, you create big as a singleton, yeah, it's easy enough. Then you give it a resource system, which is resource as an RDP. And then you just kind of map some of the resource methods to it. And that's it. All right. So it's called big, but it's not really that big. The point is that if you use the right tools, your framework is nothing. You shouldn't have to use a framework. Like, pick a pattern, pick the right tools, and just make it happen. It just annoys me when people read these frameworks and they're thousands and thousands of lines long and they have all these conventions and then I have to learn this stuff. I don't want to learn these things, I just want stuff to work. So this guy's open source now. So what we'll do is we're going to load up the web admin and we're going to click around on the web admin. So if we go here, see the code, and then if we go here, you can see, okay, so Big ships with a bunch of built-in apps for kind of testing out, GitHub, IRC, whatever. So we'll go to the admin, and then we'll go to the admin resource. So this is the documentation for the admin resource itself. It has 2 methods, listen and start. Where start is actually adding to listen. You see that listen takes in port, host, and a callback. So it's essentially saying, you know, where is the admin server to listen on. Starts the same method, and then you can see that it has a couple of dependencies. It has connect and highlight as dependencies. So if I click on those, it takes me right to the page here, which is pretty cool. So go back. So then we run the bit app. The source code for a little bit. Oops.
From the left, okay.
That's it. Thank you. Okay, so this is going to be the admin. So we require big. For debugging purposes, we just dump all the event bus. Every message goes to the event bus to the console. And now we use the big.use statement. So each one of these represents a resource, as we showed before in that big list. So admins can use account, data source, creature, node, host, replicator, application, email, HTTP. And as you can see, these are being passed an option FS, which means persist these to the file system. So what's going to happen is that there's a DB folder here. It's going to create a corresponding folder. And then you see there's like a user here. So this is, the FS is a simple data storage system for persisting to the floor content disk. So persist this to this. Use the admin, use the docs, use the mesh, and start about. We could have a little trigger syntax here. We could aggregate these events into a common listener, just tagging on around to even start a hook system, start HTTP, start admin, blah, blah, blah. So let's start this up. So first things first is that clear out the resources folder, and then clear out the connect to make sure it's not installed. So I have the app, and let's look at the file system here. So there's no resources folder in the app right now. It's empty. So I run the app. So we're going to see a few things happen here. So there's no connect installed into this little application, and there's no resources folder. So we run it, and a bunch of stuff is going to happen. So you can immediately see that now there's a resources folder, and all the resources which we're using for the app have been copied in here. This is a really important feature that it works like this, because previously to do stuff like this, and a huge problem I encountered with Hook.io development is that you're bound to NPM linking. And if you want to bring a local copy of a resource or a module and start editing it, it's a huge problem. So this is actually copying each one of these pieces in here. If you want to start hacking with this, you can just go right to the file and make modifications. You don't have to think about NPM, you don't have to think about send linking, it just works. So this started. Now let's go through the output and see exactly what happened. So we started the admin app. If we go back to the code, we see it's just a bunch of big.use statements. So every time it encounters one of those, it copies it to the resources folder. While it was doing that, it ran across the HTTP resource, which is missing a required dependency connect. NPM is spawned. This is all happening asynchronously. That's why it continues to copy. So now what happened is that it eventually made it down to the start of the app, which is hook.start. This is the first actual resource method that gets called. This is the hooking system, which we're getting to. So what happened is that it said, whoa, stop, advertising, because it's missing a dependency. So it's not going to execute any resource methods until all the resource dependencies have been met. So then it started to install connect, deferred the execution of that method. It waited until connect was fully installed. It returned an undefined code, that's great. The installation completed, and then it executed the deferred method, the hook start. And the hook system started, and it said get replicator pull, replicator checkout, we'll get to the stuff later, account create, email send, account reset, email send, and so forth and so on. And then did the HTTP listen, created the view, started it, and then we had the ad. So, we'll go to the ad. So what we have here is a web admin for resources. This is kind of big. So we'll click on resources. So what's happening here is that this interface is fully reflected from the resource definitions. So every time we use the resource in the app, the admin is intelligent enough to be able to iterate through it and then provide this. So if we go into account, for managing accounts, you can see that it has an all confirmation, and it has create, destroy, find, get, reset, update. It has the schema here. So in the same way in which I showed you the documentation, which was reflected from the definition of the resource, this is using the same type of technique in the admin. So it enumerates every property of the resource and then spits it right back out. Very useful stuff. So we can do stuff like, does it work? Say account create. Let's say like, check this. And then we just create. And it's like, no, email is required. So why did that happen? Let's go to the account resource real quick. And you can see that email is a property on the account resource, which is a type string, and it has a format email that is required. So this form, the form generator, was intelligent enough to reflect the schema of the resource and the resource method in such a way that it can throw the intelligent error message here and stop it from being created. So I'll say, okay, foo that, or no, invalid email. So again, it's intelligent enough to reflect the resource definition schema and then do the appropriate thing in the interface. So you do this, that creates it.
Good question.
Sure.
The form validation is happening server-side client side, or does it package code up for the client side?
So it's happening server side, and I'll show you how it works. So this is part of the RVP, Resource Presenter. So it's being generated server side, but with a DOM. So if I wanted to make the code isomorphic, I'm already there. So you have this view folder, which is, there's a whole view engine built into this thing that I made. So the view folder expands out. And I'll show you the view for the admin to indicate what this actually looks like. So you can see that we have all these files here. The way that the engine works is that you have a fragment, and then you have a corresponding presenter. So this could be considered the view, and then the JS file which corresponds to it could be considered the presenter. So in this case, we'll go to data source. So if I click data sources, it says what are data sources, and then it lists them here, yeah. So here's the container. None of this really matters. It's class data source, yeah. And then if I go to datasource.js, you'll see that this is a common JS module that exports a single function, and it expects options and callback. This is the real important thing. I have a query selector all bound to the scope of every presenter, so if you want to be able to do jQuery-like selector statements, which I'm sure everybody does, you can just do that. And it automatically binds the template and the scope and everything that you want. So here we just say take.datasource, which is the same as here, yeah. And then just dump in the stringify variable. So this is kind of like the beginning of the data binding system, right? So a lot of the design decisions with resource and big are make the simplest choice possible and then defer the rest to the developer. So we have the basic RVP here. If you want to implement something on top of it, there's a lot to experiment. And then you can imagine to make this work in the browser it would be very simple, because all you really need to do is just bind this to the query selector off of the browser engine. And then if we go into like the nitty-gritty of the form stuff, I can go to forms. So that's just the view for the admin. The admin calls the forms. And if I go into the form view, these get a little complicated, but I can do something like controls, inputs, string, and then string as this. And then, so this is like a generic presenter if you're creating any type of input. This is getting a little too deep into the code, so let's back it up. So we're looking at this. This is the admin view for resources. This is all reflected from the resource definition. So we do something like this. We go to creature got hired, get. This is the method before. Executes right through. And then I can make a change to this. So if I go right into the app that we're working in, I can go to the creature resource. And I can say life defaults to 20. And then I restart the app. Restart the app. And then I refresh. And that's 20. And then if I change the type or anything like that, it will reflect it as well. So the admin enumerates all the methods and all the schemas. So this is a really good way of kind of digging into your app and seeing what's going on. And then we've got a couple more things we can go through. So data sources we discussed are how your app gets persisted to a database. There's a few ones built in. Cache, FS, memory, Mongo. All of these are actually persisted by the data source, so it's self-hosted. So if we went into the data source folder, we can see this is a document for couch, for FS, for memory, and so on and so on. And then we have the hooking system. So this is probably my favorite part of the whole framework. This is the Iron Man. This is the Jarvis. This is the do this and then do that. Very similar to previous software I was working on Hook.io. So let's imagine a scenario where you have a sign-up form. So you have a user which signs up for your website, and then after the user signs up, you want to send a confirmation email. Very standard stuff. I'm sure everyone in the user did something similar to this before. With Big, you can do this without writing any code, because every resource method that we've gone over also has a corresponding event name, which is emitted to the event bus for resources. So what happens is that the hooking system allows you to say if, and then it enumerates all the different resource methods, right? So if any of these resource methods happen, then do something else. So in the case of account creation, we say if account.create. So if someone calls the create method on the account resource, then do email.send. And the way that this works is that account create, I scroll down, it probably has the code. Oh, sweet, it does. So what happens is that there's no errors. Okay, must be here. Yeah, exactly. So what happens is that the continuation for create gets passed to email.send, and email.send is smart enough to deliver your own property. Let's go over here. There's might be stuff down here. It is. What happens though is that, yes, the continuation for account create is passed to email.send, which is automatically works. We'll look at what it's actually like the mesh down there. So if you have an uplink to the mesh, this is the P2P stuff, or if you have a downlink. So if I make an outgoing connection to a mesh, or I have an incoming connection coming to me, Node.create is called. So Node.create, if you look at it, is you have a basic Node object, you have a tuple, the host, the port, and you have the username, role, status, a bunch of good stuff. Well, last time the Node was seen. And then you see the code, just create here. So every time someone connects to the mesh, we create a new node. So if I go to the mesh, you'll see I have a list of previously connected nodes. So instead of having the code for creating nodes and tracking nodes be bound to the replicator or bound to the mesh system or anything like that, you have the node resource, you have the replicator resource, you have the mesh resource. Then you have the event bus stuff, and these talk to each other, you can use these folks. Are you guys getting the idea of hooks here? I feel like I'm not explaining it too well. Anybody not get it?
So this is like if this then that, right?
Yes, if this then that. And these statements here is the name of the resource, right? And then the name of the method.
So how do you pass in the the parameters and things like that?
So there's also width. So this, let me go to the other view. So that view that we saw was handwritten. If we go to the auto-generated view for hooks, and we go to create, you'll see that there's a width parameter, which allows you to specify metadata. I'm not sure if I have an example of that checked in now, but the basic idea is if event name, then event name, with additional metadata. So the standard action for any of the asynchronous resource methods is that it continues with error or null, and then the object which is just made or created. So using that convention, any of the then hooks are expecting that options hash of the object which got created or modified to come in as the first parameter after the error. Let's see what else we have here. So we talked about data sources, backed by Joe we talked about the hook system. We're doing it again. Let's talk about the replicator a little bit. So we're going to go very quickly. So Big has a built-in replication system. So that if you want to install an app, or publish an app, or updates to an app, or any of that, it's all built in. So this is using Substack's push library. And we'll just go through the code for this really quickly. You have a push and a pull method. You set up your Git repo, you set up your tree. So what happens is that if someone makes an app using this, and they have other developers or other people who want to work on the app or use the app, instead of having to go through the installation process, cloning the repo, running the git install, running the custom build script, whatever, they can literally just do a git pull, and then they get everything they need. And then that'll give them enough bootstrap to do an additional pull, which allows them to run additional installation script with what's there. And then if you want to make a change, you can make a change in Git and do a push. And then when you push back to the app that you just called from, it's smart enough to create an event for the replication, and then it does the revision history through Git, and then it restarts the app with the new version. So if you make a change to an app, you can push it over Git and just reset it, do everything you're back. So we talked about SSH, we talked about PHP mesh a little bit, we talked about the replicator, hooks, data sources. So yeah, that's pretty much it. I want to go through the basics of it, the resource system, resources, and the big framework itself. Is there any questions?
Yeah.
Let's get started.
Oh, okay. Okay, I have two questions. One is a really neat idea to attach your package.json dependencies on your exports object. But this obviously means that your resource cannot have dot dependencies or dot name, dot description as methods. Because they will conflict with your package.json.
No. So check this out. So I'll show you the resource for admin, and we'll go to the actual index.js file. So it's all scope. So it's not bound on the module scope, it's bound on the dependencies, yeah?
Oh, okay.
And so that's it.
But it's only dot dependencies, it's not none of the other fields.
And then this loads, it's smart enough to load it from NPM, right?
That's one question. Second is about the actual object itself, the resource. This is based on an emitter, I mean, throws events, I guess. Like when you say dot create and... So, this is something that Derby.js has been trying to implement, right? They have a modeling system which works on both the server and the browser.
Yes.
And this way they're able to generate their pages on both sides. And they can do server generated. So can you use can I use Big to do this? Can I use the resource thing to run it on the browser as well?
Yeah, so one of the big development goals was to make sure that all of this code would be isomorphic, meaning that it could run either on the server or the client. So we're still experimenting with this for some of the projects that we're looking internally. I haven't really pushed any of this stuff to the master branch, but the idea is, yes, so that the whole MVP system with the resource loading and the resource loading system can namespace everything intelligently, and then it can also do the deferred loading. So if you have a whole bunch of assets, that it's not going to try to do the script injection tag until you need it. So if you invoke the resource method, the schema and the resource method are in the browser already, but the content of it and the dependencies are not. And then so we'll lazily, that's the idea, is that the same way you saw the lazy execution server side, you do the same thing client side.
So you're basically wrapping it up with like AMD modules and pushing it up.
For the most part, yeah. I mean, we've been experimenting. So I've been using some required JS. I've been trying to use Browser5. There's also the browser build tool on Boost. I think that's the one that we're using right now, that we share on the road. But the point is that if the code is simple enough and structured and logically right, making it work isomorphically is not really that big of a problem. And I'll show you something too, to give you an idea of how our resource is actually structured. So let's go into an example app real quick. So if you do comment all this out. So let's say you want to actually see what's inside Creature. So console.log, big.creature. So then you go to resources, Creature. So we'll tell it to not persist. First off. So this is a dump of the object. One of the other main development goals was to make sure that all of the internal objects and representations could be integrated very easily. There's not really any new keywords being used. You don't create instances of objects in the sense that you think of prototypical inheritance in JavaScript. There's no crazy, this property references the parent which references itself, so you can't debug and type stuff, none of that. So we have a creature method, we have a type, and then we add some the properties and we add some methods to it. And with console log, you see it's just really simple. We have name, methods are enumerated, the schema is right there. And then it also puts it on. So it puts it in two scopes. It puts it into the method scope if you need to enumerate just methods, but it also puts it in the resource scope so that you can resource down the name of the method. And then it has the hook stuff, the persist method. So there's no CRUD functionality on this object right now. It doesn't know anything about that. If I go into the resource definition and I do creature.persist memory, and then I start up again, boom. Now we have these additional methods, get, find, all, update, create, destroy. So this is kind of a recurring theme where everything is lazily injected into the object. The object can always be introspected and enumerated. And by making this structure, you can do the really cool stuff, like have the admin form just kind of magically work. So you can create a resource and not know anything about HTML or CSS or any of that stuff. But you can still do account create, because it's reflected. And then we'll do the CLI, so I'm showing that one. So we're going to node apps CLI. This is just big. So now we're running a CLI app. So it's not just for web apps. Resources get reflected across any type of interface. So the CLI is a good example of a node. So here we go. So now you see we have all the resource methods available here, right? So I can do how about account? Right, so now it iterates and it shows us all the methods on that one each resource. And I can say account all. Okay. Oh, sick. The point is that the CLI app has no idea about the resources that got passed into the app. All it knows is that there's a location that can iterate through and find the resources and find all the methods. So if I created a new resource, it would be reflected across here as well as in the admin without having to write any new code.
Just to be clear, you're now made the first proper Node admin panel that everybody's been wanting to generate. That's pretty cool.
Thank you. More questions? John?
Can you show us a bit the API resource?
Sure. So the API resource is probably the least complete out of all of them. And I'll show you the basics of how it works. So if you want to create a new API, just write use API and then just start it out, right? So for that, resources. So it's a little frustrating for me because I built this API resource before as part of a different project, and it had probably 800 unit tests. So now I need to rewrite all those unit tests, which would be great. But the point is that just have a listen method, have a version property, and then resources. So what it does is that you just set up the routes, right? API resource method ID, and then you have a handle method which passes them through. So this is just Express. So you have the generic routes for get, post, leave, all that, and then it routes it here. And then, looks like there might even be some code here. How do I start this? I should just tell you. Oh, sweet! So it's kind of looking at all though. Oh, wow, it is.
So it's like all your resources can be exposed with the API, and recipes by default, everything is exposed, or so you can restrain those.
So the only reason that, so let's look at the API app real quick. So yes, by default, everything is exposed, but it's only because I told it to use the API, right? So what you can imagine is that you can set a property on the resource to indicate, this is private, this is not private. Just literally resource.property. And then in the interface, if I wanted to go to the API now, I could say resources API index. And then I have a generic handle method, right? So I could just say something like if resource equals system. Res.in, right? And then there's a permission system built in as well, which I'm not going to demonstrate today, which uses the hooking system. So you can say if account or if system : star, then run the permissions. Then it'll defer the next thing. If the permissions fail, it's a hook, it'll stop it. The system resources are pretty sweet. We'll get to that another time. So this is just some generic string. I should read this. Enter, and it just goes through, combines the data together, and then executes the method, right? So it still is a bit of work, but it uses the same technique that all the other resources do, which is that you reflect the definition of it. So you can just know that there's a resource, and that there's a method that has parameters, and then everything else is just generic at that point. Questions?
So what usually there is a concept called REST.
Yes.
Is it similar to that? Like each resource has been exposed with the URI, and we are accessing it, and we can look the events on it, and we can say, okay, what if happens? This has to happen. So
yes. So the API resource creates a REST interface for interacting with resources. So the word resource is not the same semantic as in resource routing as you might think for Rails or RESTful resource routing, but in the case of the API resource, we do expose it as a REST interface. So that's what you see. You get like post, delete, put, right, and then the name of the resource, the name of the method, and then the ID. But same methods could be used to expose it over socket elements. You just have to versus actually doing put, delete. REST is just a reflection of the resource definition. Does that make sense?
So where exactly are we going with this? I mean, is it going to sit on top of Express to build apps, or like where exactly does it fit in the ecosystem?
Everywhere. So if you're building an app, it might not need an HTTP server, yeah. So what does Express have to do with that? Nothing, right? So in the case of a web API, it's about making the best choices. And you'll see many of the resources use very well-known Node.js modules and very well-supported ones. So the best choice for making an HTTP app is to use Express in the background. But if you want to make a CLI app, and if we look at the code for the CLI app, it doesn't have anything to do with that. More like the IRC app, right? Like the IRC app, let's see if this works. Like this. So the IRC app, the CLI app, has nothing to do with Express, but it uses the Node IRC library, right? So the ultimate goal is to have jargons, is to be able to say, do this, do that, do this, boom, done. Lower the entry barrier for everyone. Be able to create a resource and be able to spec it out through GUI even, to say these are the properties, these are the methods, and then not have to worry about IRC code, or GitHub code, or Twitter code, or CSS or HTML. It's like You want to build software, or you want to get something done? Sure. So, cool, BigBot's in there. So I started, right, so BigBot use IRC. That use REPL start, and connect to the room. And then if I go, this could work. So BigBot joined, and then if I go, big, so this is a REPL right now. BigBot, so I hit tab, right? IRC dot send. And then I don't know what the arguments are. Maybe it'll send a string. Oh, it totally did, but it didn't get the message. That used to be default. So if I say, yeah, there you go. And then IRC send is just the resource method, right? So I could just as easily call this from the web admin or from the CLI tool. So the ultimate goal is to build apps.
Okay.
And you don't, it's the Express or the website. Yes. If your app doesn't even have a website, you don't use Express. Anybody else?
So you can make a build system with this. You make a little build system app, and you can pull configuration variables from another.
You could build any sort of this. I mean, the framework's only 7 or 8 lines long, so if you can't build anything, you're doing something wrong.
So I was asking, like, you have a lot of resources. It's possible to extend the existing resource or like override some of the default tools, or
I'm sorry, just be clear.
it's possible to extend the existing resource or to override some of the existing methods with new ones, or you have to use.
Is it possible to take the existing resource and add methods to it?
Add or even extend, like override?
Yes, yes, exactly. So this is, this is definitely the system. You gotta have a good support team, no? So if you have any questions about the framework, you can go to Big on irc.freenode, and hopefully he'll be there, or I'll be there, or Big Bob will be there for this guy. So yes, so if you have a resource, so let's say we're in the admin here, I could do something like big.creature.method food functions. Is this an options callback maybe? This might work, maybe not. And then start the admin up. Oops. So hopefully it's going to crash, but creature. Yeah, there it is. So that's a new method foo, right? So I didn't modify the actual resource definition in the resources folder. Here, I did it in the app level. Here. Right here, I added a custom method at the app level. And then if I click on this, it might actually do what it's supposed to. Yeah, that makes sense. It wants me to probably explicitly call method. I'm sorry, callback. Probably explicitly wants a callback. There we go. So it's smart enough to do mark. So here's the code for this. We just created foo and then callback to mark. So yeah, you can add custom methods and same with properties too. And the before and after hooking system is intelligent enough to be able to add before and after hooks for resource methods that don't exist yet. Which is, it'll save you a bunch of time. If you get these crazy race conditions where you have to do the hooks after you enable the methods. So you can lazily add methods before or after the fact and save the hooks.
What about extending the existing functions?
To extend the existing function. So you have two choices. You can go inside the code itself and modify it again. Okay. So if I go to creature, I have the poke method, and I can just modify the poke method, right? But now let's say I wanted to modify the create method, right? For the data source stuff. So you use hooks for that. So I would say before creature create, and then there would be a continuation. And if I didn't continue, it would never make it to create. And then I could do after creature create, and that's after the creature create happens, it's going to redirect the continuation to the place. So you can modify methods directly by changing the code, or you can use the hooking system before and after. And that should cover all the cases for customization. I couldn't imagine another way.
Cross communication between modules, like cross communication between two different modules, like two different resources. So they have to go via like how do you do that?
If you have two resources and you want to,
like someone like use the other resource as a dependency, but like
Okay, so some of the resources do that. So if you go to the admin resource, it uses HTTP, right? So at the module scope, I can just call resource.use, and then that's that. And what happens is that all of the resource methods are all scoped onto the module scope. There's no code that gets executed when we require, so it's going to defer the execution of the methods until that dependency is satisfied.
So let's for a use case, let's say I want to add a special functionality. Let's say HTTP server is there. Let's say if a SSL module is available, I want to enable SSL on a HTTP module, something like that. If available, then do that. So how to do something like that?
Okay, so we have something like that already for the HTTP resource with virtual hosts. So you may or may not want to use virtual hosts with your HTTP server, yeah? You know virtual hosts?
No, I know. I actually not asked about virtual hosts. I'm asking about how to enable some functionality if there is an existing module related to that present.
Yes, and that's what I'm answering. So if virtual host is additional functionality for HTTP, so what you can do is it's extremely simple. I can just say if resource.virtualhost, then call the code for it, yeah. So it's either defined or not defined in the resource scope. So you can just do it by type of define check it out.
They have to be called in a sequence to.
It depends on the type of thing that you're doing now. And it depends.
So like it's a pre-initialization thing or it's
questions offline.
Oh, sure.
Oh, really? Oh, wow.
Last
Any more questions? Cool, thank you so much. Yeah.
Thank you.
So remember, guys, big was launched at Bangaore JS.
Sure. Thank you for having me.
Thank you for coming.